This video will talk a little about the geometry of complex numbers. Just like the real numbers have the real number line, complex numbers have the complex plane. That's because a complex number z equals, say, x plus jy takes two numbers to describe. We put it in the xy plane. We just plot the coordinates x over and y up, and we get the number z equals x plus jy. It's really just the coordinate pair x comma y. Let me connect that to the origin like that. Let's do some simple examples. See, I want a number that'll fit nicely on my diagram. Let's take z equals 2 minus 3j. Well, I go over 2. Let's say that's 1, that's 2, and I go down 3. I go to the point 2 minus 3 in the xy plane, and that's 2 minus 3j, which I can label there. How about the number z equals j? Well, I have to go up 1 unit along the y-axis, and there's the number j. One more number. How about the number z equals minus 2? Well, that's along the x-axis. I go out to minus 2. There's minus 2. As usual, when we start a topic, we need some terminology. So we'll call the x-axis is the real axis because that's where the real part of z is graphed. And the y-axis is the imaginary axis, because the imaginary part is plotted in the vertical direction. Let's note one more thing. Let's plot one more thing that we've seen, which is if I take z bar, I get x minus jy. Here I'm using z equals x plus jy. And if I plot that, instead of going over x and up y, I go over x and down y. So that's z bar equals x minus jy. That is, z bar is just z reflected in the x-axis. One thing I mentioned but failed to write down is that this plane is called the complex plane. So when you hear the term complex plane, it just means the xy plane where the points are considered to be complex numbers. Now we want to look at the geometry of arithmetic. To start with, we have addition. Addition is equivalent to vector addition. As an example, if we have 2 plus 3j plus, let's say 2 plus j, well, we know how to do this coordinate-wise. We add like terms. We get 4 plus 4j. Now, if we move over here and graph this in the plane, 2 plus 3j is over 2 and up 3. There's my point, 2 plus 3j. I can think of this as a vector in the plane, the vector 2 comma 3. And if I add to that the vector 2 comma 1, that's over 2 and up 1. It looks like this. We do the usual vector addition, and what we end up with is the sum, which looks like this. This vector right here, 4 plus 4j, or as a vector, 4 comma 4. Subtraction is exactly the same. Subtraction is just vector subtraction. I won't do an example of that. What about multiplication? We don't know how to multiply two vectors in the plane, but we can do complex multiplication. To fully understand this, we'll need Euler's formula and complex exponentials. But for now, we can do an example. Let me take z equals, well, one of the vectors we have up there, 2 plus 3j, and I'll consider j times z. Well, j times z is easy to do. That's j times 2 plus 3j. Easily we see it's minus 3 plus 2j. Let's go and plot that in the plane. Minus 3, if we go over 3 and up 2, we're right here. We have this. That's minus 3 plus 2j. Now what can we say about this? What's the magnitude of this? We have that the magnitude of j times z is just 3 squared plus 2 squared square root. 3 squared plus 2 squared square root. But the magnitude of z is just 2 squared plus 3 squared. That is, it's the same. So multiplying by j didn't change the magnitude. What about the angle? Let me just assert what we have. The angle between these two vectors is pi over 2. So what we're saying is that the angle between minus 3 plus 2j and 2 plus 3j is 90 degrees. There are many ways to see this. Let's choose one geometric way. It's easy to see that the slope of the line through the origin and z is 3/2. That's because the point z is 2 plus 3j. Over 2 and up 3 is slope 3. What about the slope through the origin and jz? Well, that slope's also easy to see. You're over minus 3 and up 2. So the slope is minus 2/3. Now what can we see? The slopes are negative reciprocals. That is to say that 3/2 times minus 2/3 equals minus 1. When your slopes are negative reciprocals, your lines are at right angles. I'll draw that perpendicular. Let me squeeze in the lesson. There's nothing special about 2 plus 3j. Could have been x plus yj. So in here will be our lesson. Multiplication by j is equivalent to rotation by pi over 2. That's in a counterclockwise direction, a positive rotation of pi over 2.